Hello everyone. So today we will start over chapter number 7. Chapter number 7 is basically the continuation of chapter number 6, where the digital video chapter, where we have discussed the fundamental concepts of the video. We have discussed the aspect ratios and some other couple of fundamental concepts of the videos. In this particular chapter, we have two main things to discuss, starting with the file size, the digital video file size, and then we're gonna talk about the compression algorithms, like different compression techniques, codec techniques, and all that to reduce the size of the video. And we will motivate this question as well. Why do we need to reduce the file size of a digital video? So in the part 1, in today's video, we're going to discuss the file size. And on Thursday, in the next video, we're going to cover the compression techniques of the digital video. So today we have two main agenda items, two main things that we are going to talk about, starting with the common file types of video. So we need to understand what are the different file types are available, which particular file type works with which kind of platform and stuff like that. The second is general. We will discuss we will calculate the file size of video. And I'll just visualize you like how many components are there in a digital video, because as you know, a digital video is basically a combination of a audio part. It does have an audio part plus an image. So in order to calculate the file size of a video, we have to calculate the file size of images, and then we will add the file size of audio. That basically what a video is. So we will discuss that, and you will see why do we need to apply compression, because the size of video is crazy. I mean, it's too large, which is kind of impractical. So that is why we need to apply compression algorithms to optimize the file size. So let's start with the common file types of video with different platforms. The first agenda item. One of the most widely used type of video is .mov. You might have seen .mov in the lab number 4. In the lab number 4, maybe you guys have when you export the final file, that might be a .mov. .mov, it's the acronym for QuickTime Movie. QuickTime Movie, which is basically a QuickTime movie player compatible with QuickTime Movie Player, a product of Apple. So this particular file type and all the features of this .mov is created by Apple. And it works really well with Apple machines, like if you have a MacBook, and Windows as well. For Windows, you need to install the QuickTime Movie Player, Qt Movie Player. That's what you need to do in order to watch these kind of videos on Windows. Another one is .avi. .avi, it stands for Audio Video Interleave. Audio Video Interleave. Interleave. And this particular standard is created by Intel. Specifically, it was designed for Windows, but you can also watch them on your Apple machine as well. Another one is .mpg. It's .mpeg or mpg. It's acronym for MPEG. And MPEG itself is basically the name of the organization, which is called Motion Picture Expert Group. So Motion Pictures Expert Group, that's basically what MPEG stands for. Platform, it's basically cross-platform supported. But specifically they have created this particular standard for DVDs and Blu-ray. Then we have another standard .mp4. MPEG-4, again, Motion Pictures, MPEG-4, Motion Picture Expert Group, they have created that. And this particular standard, again, you can run it or watch this video on your Apple machine and Windows machine. But specifically, .mp4 was designed for browsers to run a video, watch a video on the browser, especially like YouTube, Netflix, all these. They are basically specifically designed to run the videos on browsers. Then we have another standard, a common standard, .FLV. FLV stands for Flash Video. Flash Video, that's the acronym, and the created by Adobe. So Adobe, they have created that, and again, it's basically a cross-platform. But you need an Adobe Movie Player in order to watch it. Cross-platform means you can run it on Windows, Apple, Linux as well. Another one, the last one, of course, in the list, it's .WMV. WMV is Windows Media, in fact, sorry. Windows Media. And created by Microsoft. Specifically, it was designed for Windows, but you can also watch .WMV on Apple machine as well if you have the software Windows Movie Player. If you have a Windows Media Player, if you have that, you can watch it on Apple. If you don't have that, of course, you can also run it on VLC Player. So you can download a VLC Player and you can watch it on any platform. So technically speaking, .WMV is a cross-platform if you have the required software for you. Now, why these file types are very important to understand, because when you create a video, there are three main things that we need to consider. So when we do the video editing, these three factors are considered to create the file type, because three factors to create the file type. The first factor to create a file type is file size restriction. Second is the intended audience. And the third one is future editing. So these are the main three driving factors or characteristics behind deciding the file types, like which file type you need. So for example, let's say if you wanna create a file size for, let's say for web, okay? For web, if you wanna create a file size. So of course for web, for uploading, downloading, we have to make it like easy to download, or our intention is it can be watched if anybody has a low data rate. Because for example, if you have a video size very heavy, or for example, a large video size, so receiver will see the video like it's going to be a very choppy for the video, for the receiver. For website, if you want to upload a video on the web, so the most important thing is the file should be highly compressed. You should have a small file size. Similarly, for example, if you are creating a video for DVDs, or for example Blu-ray, so again you have to decide, as you know, we need to use MPEG 4, MP4, or MPEG 4, or MPEG 2, in fact, for DVDs and videos. Another factor which is again used for to create the file type, its intended audience, like which software they have, for example, which platform they have, which platform users are going to use in order to watch the movie, which particular software they got. So platform or the software. And again, another characteristic, that is future editing. If the video will be further edited, so what we do is we have to use the uncompressed file, like the original source file. Uncompressed file, we have to use that. Or for example, we will use a file which have been applied lower compression. If the lower compression has been applied, or the file is uncompressed, that's going to be a best fit for the future editing file. So these are basically the three characteristics. While video editing, these three factors are considered to decide or create the file type. Let's come to the digital file size. As we have already talked about, the video size is crazy big. Like, why it is too large? Because the videos are very large size as compared to any digital media. The reason why? because video, let's say for example, let's try to visualize it. Let's try to visualize it, and then I'll calculate a video file size for you guys. That would be, of course, we're going to use it for our lab as well. So let me just show you how a video looks like and why the video size is too big. So let's say we have a video, and assume that this video duration is 1 second. Let's microscopically see the video. So in the video, what we have, let's say this is basically your video duration 1 second, and assume that our frame rate is FPS is, for example, 25. So 25 frames per second. And what do you need? And as you know, frames per second mean pictures and audio. So we have 25 frames. Let's say this is frame 1, 2, 3, 4, 5, etc., up till 25. So starting from here all the way to 25. And each particular picture will have an audio part, something like that. This audio part for this, audio part for this, and all the way. So we got 25 pictures. We have 25 pictures, 25. And for each picture, we have 25 audio, which are connected, of course, but I just want to make you understand so you have a better understanding about video. Now, let's microscopically see that in the digital terms. This is basically a picture. So for example, that's a picture. Let's see the picture first, and then we'll see the audio. If this is a picture, like this is the frame number 1. In this particular frame, what we have mainly pixels. Got it? So we got small boxes. So picture is basically made of pixels. Okay, that will based on the resolution. And each particular pixel will be made of bits. Got it? So we have a frame like a picture, like this picture, and this particular picture is made of pixel, like these small boxes, pixels, and each pixel will be made of bits. Similarly, let's check it out. This is basically your audio part. Audio, as you know, it's an analog. Typically, we convert the analog audio into digitized. So we collect the samples. Remember, we collect the samples. So sample 1, all these samples. And this sample will depends on the sampling rate. Like how many samples will be collected in 1 second or so. So samples, and then for each sample, this is basically, each sample will be made of bits. So just imagine for a frame where we have a picture plus the audio. Picture is basically made of pixel. Each pixel will be made of bits 00001. And then we have the this audio part. Audio part will have some samples, something like that. Each sample will be of certain number of bits. So this is just for one frame. And we got 25 frames in 1 second. So we have the 25 frames per second. So like we have pictures, pixels for all the frames plus all the audio part as well. So that basically what makes a video. Let's calculate the size of the video. It will give you some better understanding. I'm gonna give you a simple example for that. I mean, just a simple formula based, but again, you can get it done conceptually as well. If you want, I will definitely discuss that in the class as well. So let's solve with a simple example. So we got this example here, and that's basically the description. So what is the description? We have, for example, let's draw this. So and again, we will solve it. I'm going to explain you with concept as well. So for example, we have a video. And the video duration is 1 second. So 1 second is the video duration, okay? And how many frames we have? 30 frames per second. So we got 30 frames per second. So it means 30 pictures all the way. And again, having an audio part, okay? And each picture, pixels per frame. Pixel per frame is 1920 multiplied with 1080. Like this is the total number of pixels in this picture. In one picture, one frame. And each particular pixel will be of 24-bit. Like this is one frame. Like if I see you, show you here. So how many pixels it will have? It will have 1920 multiplied by 1080. This is called 1080p videos. And each particular pixel will be of 24 bits. Got it? So you can calculate how many bits will be there in one frame. Then we have an audio part. Audio is stereo, 2 channels. Number of bits, again, samples. So in 1 second there would be 48,000 samples, and each sample will be of 16 bits. So we have to calculate the video file size. Very, very simple. The formula for this, because as we have already talked about it, so I'm going to actually show you with simple example. So as we already talked about it, if you want to calculate the video file size is equal to file size of image part plus file size of audio. So we need to calculate image file size plus the audio file size. Let's start with the file size of image. The formula for file size of image is file size of image. The formula is total number of pixels per frame, total number of pixels per frame. Okay, like in one frame, how many pixels, multiply by total number of bits per frame, multiply with frames per second, multiply with duration of the video. Please remember, this duration of the video should be in seconds because all the units will be treated as seconds. Then the second form, this is the formula for file size of image. Then file size for audio. Size of audio, the formula is sampling rate, like number of samples per second, sampling rate, multiply with number of bits per sample, multiply with number of channels, then multiply with duration of the audio. And audio and video duration is going to be same. It's going to be again in seconds. So let's get started. Let's solve this formula first, and then we will, whatever the result is going to be, we'll put it here, and then we will solve this one. So firstly, let's solve the image part. Let's solve the image part first. Image part. For image part, so file size of image. So what is the total number of pixels per frame? If you guys see here, total number of pixels per frame is this 1920 multiplied by 1080. So 1920 multiply with 1080 multiply. This is basically the total number of pixels per frame. Okay. Next is the total number of bits per pixel, which is also given 24 bits per pixel. If you see 24 bits per pixel, so we will multiply with 24, multiply with FPS, frames per second, which is 30. It is also given. Duration of the video, which is 1, so it will not change, make any significant difference. So if you solve all this, so what we will get is, so if you multiply this, just give me 1 second. It's going to be 49766,400 bits per frame. Oops. Multiply with 30. If I multiply with 30, so the final answer is going to be 1492992,000 bits. So you can multiply together. I just multiply with step by step, so that's why I have this answer. So now this is basically the file size of image, like the image part, like how many images are there in the video. Now we need to, this is a big bits and it's a crazy number, so why don't we convert it into bytes? As you know, to convert this into bytes, what we need to do is 1492992,000 bits divided by 8. So once you divide it by 8, the answer is going to be in bytes. So if you divide it by 8, answer is going to be 186,624,000 bytes. Still number is too big. So let's convert. Let's go to the next unit, which is KB. So to get to the KB, we will divide it with 1024. So divide this with 1024 to get the answer in KB. If you do that, the answer is going to be 182,250 kilobytes. Still too big number. Let's go to the next unit, which is MB. To get the answer is MB. Again, divided with 1024. Once you divide it, the answer is going to be 177.99 MB, megabyte, which is, which is fine, because in GBs, of course, we have to, if you want the answer in GB, again, divide with 1024. Okay. So this is basically over the image part. That's basically what is the image part. So we got 177.99 MB plus, let's see the file size of audio. So for file size of audio, we're going to run this formula, and we can run it here. Sampling rate is 48,000. So sampling rate is 48,000. So 48 kilohertz. So we can actually put the sampling rate here, 48,000. Okay, sampling rate multiply by number of bits. If you see, this is the sampling rate, and number of bit is 16. So we will multiply this with 16. Number of channels are 2, and duration is 1 second. So if we solve this part, so we will get it's 1536000 bits. Okay. So to get the answer in bytes, we need to divide. Let me just do it the next page. So this is for the audio part. I'm going to divide it. So 1536000 bits. This is for audio part. I'll divide it with 8. 1536000 divided by 8 to get the answer in bytes. So the answer is going to be 192,000 bytes. So this is in the bytes. So let me again divide this by 1024 to get the answer in KB. So 192,000 divided by 1024 to get the answer in KB. It's 188 KB, which is fine. Still, we can divide it with 1024 to get the answer in bytes. But 188 KB is reasonably fine. So this is basically the audio part. So total size, file size of video is going to be, what is the image size? The image size, this is what we calculated, 177.99 MB plus 188 KB. Please remember one thing. It has to be in MB, then we can add it. Otherwise, we cannot add it. I'm just rounding off. Let's say if you further divide it, 188 KB divided by 1024. So if I calculate that, so it's the 0.183 MB. So let's use this because MBs can be added, not the KB. So let me just put this value here, 0.183 MB. So if you add it together here, plus 177.9, let's to be exact, it is 178.083 MB. So approximately you can say it is 178 MB file size for 1 second of the video with that specification. And just imagine, for example, if the size, if the length of the video is, let's say 10 seconds, it's going to be 1.7 GB. And if it would be, let's say 10 minutes, just imagine 10 GB or so. So this is basically, 10 second is going to be 1.77 GB. If it would be 10 minutes, it's going to be 177 GB. So just imagine, this is basically crazy. Like the overall duration of the video is going to be, let's say for a 2-hour movie, it's going to be in terabytes, which is impractical. We're going to do a couple of numericals related to video size. So during the class time, please let me know if you guys will have any kind of questions. So please do let me know. Thank you.